Hello dears, we are here to simulate 2D crack growth with XFEM method. In this method, the crack will be modeled in a separate part and it will be located on the considered place in assembly module. In this video, I want to use max PS maximum principal stress to see the crack growth behavior. In this criterion, the initiation of crack growth occurs when the F parameter reaches 1. Let's go to the software and create a part in 2D space. Deformable and shell. Consider 10 for approximate size. Choose rectangle and input 0 and 0 and 5 and 5 to draw it. You can draw the crack in the correct place so that you don't need to move it in assembly module. As I said before, you should create another part for crack, 2D planar and wire. Consider 2 for crack height and 1 for crack length and draw it on the left side of the sheet. So input 0 and 2 and 1 and 2 respectively. As you see, the crack has been created. Go to Property module. It's important here to input max PS properties. Create a material and name it steel. From general density, input 7.85 E3. Mechanical elastic, input 200 E9 and 0.3 for Young's modulus and Poisson's ratio respectively. Create a section in solid and homogeneous for steel material. Now assign the section to the sheet. It isn't necessary to mesh or create a material for the crack. Go to Step module and create step in Static General and name it Crack Propagation. Go to Load module, create boundary condition in initial step. Select bottom edge and choose Encaster. Again, create boundary condition and select the top edge in displacement rotation type and consider 2e-3 and 3e-3 for u1 and u2. Go to Mesh module, select the part, seed part, and input 0.1 for approximate global size. Choose Sweep technique from Mesh Control and mesh the part. Here, from element type, deactivate reduced integration. Plane stress is for low thickness sheets. That means we don't have stress in Z direction. I will run the model in plane stress mode first. Submit the job and wait for it ends. In some increments, the software tries almost 5 times to converge the problem. Go to the results. To see the crack better, increase the value from deformation scale factor equal to 100. As you see, the crack is growing. As you see, the solution finished for 23 increments. As the solution is progressing, the crack is going forward. Here you can see the displacement values. If you can apply loads uniformly in real situation, the crack growth behavior will be closely same to the results of software. Because we have regular elementation, the results will be accurate. As you see, the analysis has finished after 128 steps. In last steps, the software reached to convergent response in one trying. Now you can see the crack growth clearly. And also you can see it frame by frame. from create XY data ODB history output, you can see some outputs such as creep, dissipation, energy. That it is 0 as you see because it isn't defined. But damage dissipation energy isn't 0 because damage is happened in the sheet. And also we have internal energy. Kinetic energy and loss of kinetic energy should be 0 because the model is in static mode. Strain energy that is 0 after separation. And the viscous dissipation that isn't 0 because we have defined it.
I hope you have received the items that you're looking for in this package. Follow us on our social page and website. Have a nice day. Hope to see you again.